up 20 meters. Copy that. I'll proceed a little closer and then back up towards you. Feeling a lot of tether here.
We have visual on the bottom now. Looks like at least mussel shells, maybe live mussels there too. This is a big mussel bed here.
1.2-ish, I think. Yeah, we were actually running at the same. We lost some weight here, but we added the lead. So yeah, probably about 1.2.
There.
I was watching this dive on Lake 2, and this was a massive mussel field.
Back up towards you. Waiting for your turn around. Yeah.
It looks like more shells than live mussels here at least though.
Yep.
Some carbonate there.
Workshop, getting on a tether. Co-pilot. Copy that. Keep it around. Yes, I am. Can we get someone up here to help switch around?
Very, very good seafloor visibility. That'll help when we get to the seep.
Checking my tether, and then I'll center you up. Copy that.
Well, some of those mussel shells are large, aren't they?
Probably. Yeah, I guess so. If you use the funnel there as a scale. What is that, 15.5 centimeters wide?
15.2, yep.
15.2.
Well, the cylinder is. The flange is bigger. Flange is probably 20.
Right, right. That's right. We estimated about 20 to 25 just visually.
So some of those shells are pretty long.
Right. It'll be, you guys kick on the lasers here. Southeast, maybe.
Yeah, instead of us just guessing, we'll put on the lasers.
Yeah, so lasers are 10. Some of those shells are at least 20, maybe longer.
And come around that side of you. If you want to follow me, and keep an eye on the tether. Alrighty, you got it.
So these mussel shells are probably from the species Bathymodiolus brooksii. They're the only ones that I've seen that are that large, and they occur pretty commonly at this depth. So unless there are some other species I haven't heard of, I'm pretty confident in that assessment. Although I saw one there that looked like Bathymodiolus heckerae too. They have kind of a thinner curved shell. So maybe both are here. Or were here. Were living here at one point. Yeah, I see some tube worms there too.
Yeah, the lasers are on now. The lasers are 10 centimeters apart. It gives you a pretty clear view of the range and sizes of some of these shells on the seafloor. Some quite large. Ship's moving now slowly to the southeast. We are some tens of meters northwest of the seep site that we're looking for. Some question about where it is exactly, but it's in a circle of radius, only 10 to 20 meters. We should encounter it. We're looking for bubble streams on the Sirius sector scanning sonar now. Nothing yet.
Yeah. And we're looking for a physical marker 28, which is probably a smallish piece of syntactic foam with the number 28, with some reflective tape and the number 28 drawn on it. Was a magid crab that we just passed there on the left.
Now, would these mussels die just from a life cycle situation, are they being predated by anything, by crabs or?
I suspect that, I mean, this is very extensive. I suspect that they were inhabiting a seep, and for whatever reason or other, the seep stopped. And they don't have that energy source anymore.
Right. But you haven't.
I mean, they might not have all died at the same time, right?
You haven't watched crabs actually eating. I mean, you haven't seen predation of these bivalves at all by anything.
The only time that I have seen crabs eating bivalves is when we crush the shells ourselves.
Really?
While collecting them or something.
Right.
I don't know if that's the only time that it happens, but I think that that's my hypothesis, is that crabs would only be able to smash the shells of littler mussels. Otherwise, these really big ones would be too big for their claws to crush.
Fair enough. Fair enough. But there's nothing toxic about the meat of these bivalves. I mean, they are eaten if they can get at the meat.
Yeah, and that's a good question. I suspect that I wouldn't want to eat these mussels because they might not taste very good,
right,
being in a sulfurous environment.
Right, exactly.
But I've seen crabs eat them, and certainly their stable isotope signatures of some crabs that live around here indicate that they are deriving some nutrition from seep input. So that doesn't necessarily directly tie them to mussels, but
right.
They don't seem to be toxified by eating stuff coming from seeps anyway.
Okay, well, that's great. Thanks. It wouldn't surprise me. You're on the flank of a salt dome. Wouldn't surprise me that you've got solution-based fissures. Could be related to proximity of the salt itself. Could be collapse of underlying hydrate, which I think we saw evidence of over on the Biloxi Dome.
Yeah. So Survey 1 was just telling us that there in this area there are fissures, and that's where the live mussels are. The live mussels are associated with these fissures, right?
Yeah. We now have a target about 10 meters out on the are we on the Little Herc sonar? About 10 meters out, which could be a stream. We've also got a pretty prominent set of targets more than 10 meters out, about 090 to the Little Herc.
I think I can make it, Jeff. At least get it in sight. Yeah. 50,
that would be about right. That would be about right for one of the designated locations for the seep that we're looking for.
well, 15 off is all right. Yeah, I got about 5 meters heave going on too. Yeah. Now that you're close to me, you come in close enough to cut it. Done with it? Oh, we got bubbles, right?
Lots of looks like lots of bubbles coming out of the seafloor there.
Got a whole range of bubbles coming out here now.
Hold off a little bit. Coming down.
Very, very thick concentrations of shells at the seafloor now.
So I wonder, are there any live mussels around where these bubbles are coming out?
I believe,
Oh,
I remember looking during the dive during leg 2, and there certainly were mussels right near where the bubbles were escaping in the continuous stream that looked alive.
Hey guys, I'm not saying this is the spot we were at last time,
No, it certainly doesn't look like it.
but
Tom asked if we're sure that these are bubbles right here, and I don't know, just a moment ago it seemed like there was quite a lot of stuff rising straight up from the seafloor, so certainly looked like bubbles to me.
Watch leads pilot here.
Yep.
Yep.
So the one risk we have here is that our cylinder is plugged, and we can certainly get closer to these bubbles, but we do risk catching
Yeah.
some.
Right.
I can kind of see them off in the darkness there, and I'm happy to get closer, but we do risk getting
Yeah.
earlier than our time.
Yeah, Tom, did you? The point is that our cylinder is closed now. If we We do not have the luxury of casting about in areas where there are disseminated bubbles because we're going to catch some on the way. Do you want to think about that? I mean, we're certainly looking for a seep that's got a continuous stream of bubbles. That's what we saw during leg 2, but this is a gas-rich area. What's your thinking?
Yeah, Jamie, if I remember, this was the previous dive that they did. Oh, yeah, I see what you're saying. There's bubbles.
Yeah, we've got bubbles disseminating over a broad area here.
Yeah, I totally see that now. So my mistake before, I just wasn't seeing them. I think that yeah, this will mess our experiment up a little bit. So my memory before is that we saw kind of a wide distributed area that looked this, and then that really strong seep. And it's going to be hard to find that really strong seep and avoiding this at the same time.
Right.
Are we getting anything in the cylinder right now? Can you get up and have a look?
Can you can we pan up and take a look at the cylinder right now and see if we're getting any bubbles up there? Kind of hard to tell, Tom, but it wouldn't surprise me if we're seeing something.
Tom, can you hear?
Yeah, it doesn't look like there's a lot.
He's hearing me, so I'm talking to him.
To fill, as we know, but there's not much in there right now. So, yeah, I think we'd like to we try to avoid positioning ourselves over those areas as best we can and just see how it goes.
Yeah, I mean,
That's a tall order.
ROV nav, we probably want to avoid the area right in front of us that appears to be an area of bubble escape. Maybe we want to circle around a bit. We know there are bubbles directly in front of us, so maybe we want to move left or right, your choice, to try to make our way to one of our designated targets. I mean, we probably can't avoid this completely, but.
Jamie, if you could drop a nav marker here, that would be great, because this is certainly a place that would be of interest to us with the calibrated grid.
Okay. ROV nav, could you drop a marker here? They may want to come back here and do a count tomorrow with the grid. So if you can do a marker here, that would be good.
Jamie, is this what we see right in front of us in the little Herc scanning sonar, or I don't have a good sense of the range there?
Well, we're pretty close to the seafloor now. We're only about a meter off. My guess is you're seeing scatter related to these mounds of shells all around us.
Yeah, I see one sort of area that right in front of us.
Right, and there are areas on either side as well. These shell mounds have some relief, and they're good scatterers. So, I haven't been here before, so I'm a little handicapped.
Yeah, Thomas, Dave Wright here, sonar operator. On the right-hand side of the screen, you'll see the Sirius sonar, and it's running at 385 kilohertz, and it's clearly showing bubbles in the water column before the first return. If you can see the cursor, this is first bottom return. This is bubbles,
right.
And this is Herc and bubbles. Can't really resolve, but that's the picture. None of this shows up at 725 kilohertz, only at 385.
Okay, so is it your interpretation that those bubbles that we're looking at right now with Little Herc, that's the same as what you're pointing out on the Sirius scanning sonar?
Yes, that's correct.
Okay, that's great. Thank you. Well, that didn't take long to find bubbles, did it?
I'm seeing bubbles off to the left now. I think this entire area is leaking gas.
Yeah, my memory before, I think the first thing that was found was that really strong seep, which is the one where marker 28 was dropped. But then later on, we found more sort of dispersed seep fields like this. Except my memory was that there were more live mussels at those locations. This
Yeah,
is mostly
all
like
this gas
shell.
coming out would explain why there's so many mussels, but I don't know why they're mostly dead.
Right.
It's interesting.
Maybe this is.
Well, and we haven't taken a really close look. There may be living mussels in among these bivalve shelves too. We haven't started to do a really close look at the seafloor. My guess is there are some
Well,
live
I
ones.
think there are a few live ones, but I mean, you can see where there's sediment and then just dead shells sticking out. I mean, I've seen extensive live mussel beds, and they don't look like this. They look, dark, like a bunch of live mussels. So I mean, you're not going to see live mussels buried in the sediment really so much.
Yeah, I'm gonna pull up that video from yesterday, or from the previous dive. Interesting spots.
Yeah. Right. And so Bob says that mussels can't use the gas. They need the methane to be in solution. So that makes sense.
Now the mussels using the methane directly or higher up the chain?
Yeah, so the mussels have bacterial symbionts that are, so these particular mussels have two types of symbionts. One type is methanotrophic, and those use the methane directly. So they oxidize the methane, and they use it as a carbon source. And they also have chemoautotrophic symbionts that use sulfide as an energy source to fix carbon dioxide in the water column. But most studies have shown that when they have two types even, they have more of the methanotrophic kind. And it seems like more of their nutrition is derived from this methane oxidation. So they do use it, but as Bob said, the methane needs to be in solution, so they can't just use the bubbles. Okay.
Tom, we need to get a read from you here on what you want to do. We're sitting over disseminated streams of bubbles, and we're collecting gas. So do you want to drive fast to potential locations for the seep? What's your pleasure?
Yeah, let's drive fast and try to get to that other seep. This actually, I just pulled up the video from the last dive. This looks almost identical in nature to the seep we saw that was distributed before. So my preference would be, unless we've already got a lot of gas, it's going to be hard for us to get a good measure here.
Yeah,
let's go to the other seep.
ROV nav, let's make progress to the southeast towards what we think may be our marked seep. Well, it looks southeast from where we are right now, according to HIPAC.
Okay, so you're hit. You might be able to get there on your tether. Let's see. Yeah, just don't have a ship maybe. Right. Roger.
That looks like more live mussels there in the foreground here.
Jamie, I just to fill you in on the rationale for going to the other site, if we only capture, you know, if we can only position over a quarter of the dispersed seep or less, we'll have a hard time getting an estimate of the overall flux rate from that location, and we won't know what portion of the seep we're actually capturing. And so this other site, it seems like we'll be able to capture the whole thing. So motivation going to the other site rather than staying at that one.
Yeah, I mean, the trouble is we're now do not have the luxury of an open cylinder while we're looking around. You know, it's, you know, we're having to make one compromise after another here. So we're always, you know, we're making the assumption here that we can switch the gas on and off when we want. And that's just, at this location, that's not true. We're probably picking up a few bubbles on the way.
It's possible. We can always pan up and have a look and see what's in the bucket. My hope is that those dispersed sites aren't plentiful. If they are, then as you say, we're going to run into trouble with our methodology here.
You think it's harder to see in the distance because the camera is looking down? Some tube worms.
come back to your right side now. Yeah, it's a better track. It certainly looks like you start whistling that vents out. I think this brings us over that diffuse flow you saw, so I'm moving a little bit faster.
Yeah, I think we don't want to get into these flows. If you think you've covered ground that has got disseminated gas, we want to try to avoid that.
Roger that, Watson.
Having said that, I don't think this marker is where we thought it was.
There's the tether. Help me out there. Okay. Yep, come back in towards you. Roger that.
Right. Bob Carney said that it's about 1 to 2 meters away from an exposed carbonate. Here's an exposed carbonate, so could be it.
Might be getting there though.
This bubble signature, the first stream that came on was the strongest, was even more of a sonar on the native site.
Rolling. Are we getting more reflection? Or is this more stuff in the water?
I had my head down for a minute, Bobby. Did you come anywhere near the bottom?
No, he's been high up.
Okay, then look around and figure out where it's coming from. That's a clue. If it didn't come off of you, I would turn around, get a little closer to the bottom, turn around, and go back towards you.
Roger that. Here's the carbonate that we're interested in. Right, coming back towards all dust. Okay.
Yeah, those look like living mussels off to the left, huh, Aaron?
Yeah, yeah. Pretty big patch of them there.
Yeah.
And underneath that carbonate too, as Dave was saying, they do kind of seem to be in a fissure-like pattern.
Right as the ship heading west. It's on the upper left corner.
320.
Thank you.
Oh, Carlson, we had a northerly ship heading last time.
Yeah, we had the opposite ship heading.
Okay. That explains things.
But I figured just moving the A-frame over would get us. We're usually about 10 meters off the stern, I think. Usually it works just to park the A-frame over the target. Plus or minus 10 meters or there.
So Bob suggests that we follow this rock ridge off to our right, because it matches his memory from the leg 2 dive where they dropped the marker. Yeah. We're wondering where all this dust in the water is coming from, since we haven't gotten close enough to the seafloor to stir it up with the ROV. And to Bob's memory, the marker was dropped on top of the rock surface. Does that sound right to you guys who were here when that marker was dropped?
Yeah, it was dropped off to the left-hand side in a clear patch.
In a clear patch.
Off the stern right now from the center. At about 10 meters. A little less, 6 or 7. I lost her edge. Do you want to go back and follow it the other way around?
Sure. Going back to follow that edge the other way.
Well, you've still got edge in front of you to the right of your field. I wouldn't reverse. I didn't see anything like bubbles along that ridge.
Okay.
So I don't want to give up on this course. You're headed southwest at the moment. Looks, there it is, right there, right center part of your field.
Oh, true. Thought we lost it.
That's a big target, though. It could be.
That's making me think the marker might be either directly below Sirius or slightly to the north.
Well, go ahead, because it looks like we're headed back to the disseminated bubbles we came on when we first encountered the seafloor. I don't want to go back there. So if you want to turn north and head for Sirius, go ahead.
What do you say? Or do you all might be considering? I think that target that Dave has in his sonar might be, if that's a bit to the north of Sirius and you as a target, that might be the marker. Okay, so we should try to get there without crossing through the disseminated bubble flow. So that's due north, I'll hold still here.
Some more exposed carbonate and tube worms, live mussels.
Meters off the port side, so 20 meters east. Sorry, 20 meters west. Just went from south to north. Got confused. Yeah, 20 meters, 285. From me, so you'll probably have to head more southwest. Or we can search the area in between also. Yeah, the diffuse flow is still like in between us and the bubbles. I guess if we definitely want to miss that, we'll have to do a ship move to the north. Do a box around it.
Looks to me like you can drive to the southeast without moving the ship and start looking at the possible markers to the southeast of where Little Herc is right now. That's the part you haven't looked at yet.
Okay, it's straight ahead of me now, 25 meters. surprised we're not seeing anything in your sonar.
Hey, Jamie, I agree with you, southeast. I just looked at the video. I just posted this on the chat too and gave you a position.
You know, ROV nav, I think we
Meters to
need
the
to move
southeast.
Herc to the south and east.
Stand by here, Lucky.
Yep.
Okay, what's that right there?
I believe it to be your marker. It's above the surface.
Yeah.
I can zoom in if you want.
So we
Okay, let me come up and see if you can sneak in underneath the funnel.
so we think that the marker is straight ahead of us.
I can't get anywhere close. I might be in my tether.
Yep.
Go ahead.
Ah,
it
there we
is.
go. There's a there's a marker.
Gonna pull back.
I don't see any bubbles though.
Now let's make a ship move until we can get closer.
Well,
Basically,
maybe there aren't so many of them that it's so obvious from this far. I don't know.
might be flat back sonar.
Okay, bubbles are, the old bubbles are 5 meters correctly.
Just keep an eye on that. Yep, just gonna keep it right here on my funnel. Yeah, that's the next step.
ROV nav, if you have the tether for it, I'd like you to drive to the marker and drop an electronic marker over it so that we can see it on HiPAC. Have you got room?
Actually, we don't have the tether right now to do that. We're gonna have to wait.
Roger that.
So the next step now is the bubbles were actually 5 meters bearing. What was it? 115 away from the marker. It's written on the left-hand page of the marker.
So Tom would like to see the EK60 now, if we could do that.
I don't need to see it, Aaron. I just would like you guys to record it
Oh,
during
okay.
this operation if possible. I kind of
Okay.
like seeing the nav display
Okay,
right now.
all right. So rather not see it, but record it.
Thanks, Aaron.
Oh.
Yeah, I really think it was. I think we came down on the marker and we're looking at the bubbles.
Could be, and you know that was a week ago, gentlemen. I mean, there isn't anything that says that these seeps are invariant in time. Could be looking very different now than it did a week ago.
28.
Probably gonna have to make a second move as well, but bonus. I think the bubbles are closer to me now. So the marker's there, but they'll be 5 meters closer.
As I recall, this
So maybe there's the diffuse flow is the big one, and then there's the smaller flow with the mussels is the small one.
But they're going to be going across the bubbles at this point.
You can see the marker now just above the flange on the left side. We're coming up on it slowly.
You think the bubbles are on the edge, as in that edge where there's mussels, the edge of this carbonate?
Yeah, I believe it is down at the bottom of this mound.
At the bottom of this mound. Okay.
Yeah, it's probably coming. They're probably coming out from that ledge that we're on top of right now, but we're not seeing very well. We're going to get around and look at it from the other direction. But I'm still not seeing a good stream of anything. Right on it. Yeah, I think that's right.
Back off towards you now. I wanted to come up first on the man, find the target, and I'm gonna come back and go around the ledges here.
So we're going to go around to the other side of this ledge and look at it from the other direction.
I remember this right before we dropped it. Science wanted to image the mussels before we dropped it. Is it to the left of the slope, or if you just get over the marker, it's bearing 115. And 115 marker, so it's going to be out this way. Yeah. get yourself over and then face 115. That'd be the switch. Let me go back to the marker then. Coming to the marker then. Yeah, you could even, I did not hear you as people were saying they wanted to see this ledge.
Well, I want to be a little careful coming up and over the ledge without spying bubbles. I don't want to inadvertently get the funnel over a bubble stream before we've had a chance to sneak up on this marker from several different azimuths, right? So let's be careful about it.
Watch the co-pilot.
Yep.
The bubbles are actually 5 to 10 meters from the marker.
Okay. And
Out the marker there just so it wouldn't interfere with the props or the bucket.
Roger that.
So they're heading 115 away from it. So
Okay.
just getting over it, and then we'll face that way, and we should see them.
Roger that. Thank you.
Survey 1, co-pilot. Did we have a good view of the bubble streams and little head sonar when we came up in the...
So what the co-pilot just said is that the bubbles are about 5 to 10 meters from the marker at a heading of 115. So we're going to get over the marker and then look in that direction, and we should see them.
You can stay up for a bit too.
Yeah, there's the crab.
You see those two bubbles right to the left of the funnel? Slightly there's
The crab was there last time.
There they are. All
Oh,
right.
there's those bubbles off to the, a little bit to the left of the funnel.
Okay, Tom, when they get organized here, you got to give us a feeling for how much video you want to shoot before we get up and over this stream.
Okay. Yeah, we'd like to go get a look at the base of it, similar to what we did the last time at the Biloxi Dome with the lasers, if that's possible. Looks very similar to what it looked like during leg 2, during Tim and Ben's dive.
Yeah, it's encouraging that it's still perking away there.
Before you put that bucket in it, make sure you take one more look and see if you can see anything in the bucket right now that's obvious.
Yeah, it shows up really well in your sonar.
We're going to want to do, before we make any collection, and while we're shooting some video of the bubble stream, we're going to want to take a good visual inspection of the bucket itself to see if, in fact, we've inadvertently collected any gas before we decide we want to collect it. It's a good view of the bubble stream now. Just to the left of the lasers, we're adjusting our exposures. We're going to want to shoot some video here of the stream, probably at a relatively at an angle that allows us to see the bubbles in the water column. So we're going to want to bring We're going to want to bring Herc down nearer the seafloor before we do that.
Actually, Jamie, what we really like is a frame of reference for when we're looking at those bubbles. And that mussel right on the, just our side of the stream, if we could get the lasers on that and then look at the bubbles as they leave the source, we'll have a good frame of reference for sizing those bubbles.
Do you want to zoom in more than you are right now, or do you think you could size bubbles at that size frame?
It's hard to say. Zooming in would be good for sure.
Yeah, at some point you lose the lasers. We can give you as much zoom as we can to keep the lasers near the bubble stream.
Well, they don't have to be done in conjunction. Once we get the size of that mussel, then we know what it is.
Right.
Probably know that roughly anyway. And then a nice zoom on the source for a couple of minutes will give us a good measurement, I think.
Yeah, gentlemen, once we get set up, we're going to want to put the lasers on a shell near the bubble escape so that we can get a size reference for the bubbles like we are now. And then once you're set up and stable, we can shoot video here. That's excellent right there.
Yeah, that's beautiful. That's a really nice shot.
Once you're stable, I think we're going to want to shoot 5 or 10 minutes here, pretty much as you've got it. We can adjust exposures and so on. It would be good to get a little more visibility high in the field of view.
I think that fill operation is going to go pretty quickly, Jamie.
Yeah, I think you're right, Tom. I think it will. Gentlemen, we're going to want to try to keep the shadow of the bar off the seep site if we can. So we're going to want to try to keep the lasers in the. Yeah, that's going to be the hook. We want to try to keep as much light on the source of the bubbles as possible. Right. Yeah, that's a good setup you've got right now. Yeah, that's great. Yeah, Tom, you let us know how much you would like this. We've been set up now on this for about 3 or 4 minutes.
Yeah, Jamie, I think if you can hold this position for about 2 minutes, this is really great, and then we can position for a fill operation.
Okay. ROV Nav, if we can hold this position for 2 minutes or so, he thinks he's got enough video, and then we can set up for a capture. No, we don't want to do that. So that's a good view right now. Right? I think he prefers to have a sense of size. Tom, do you want to have the lasers stay on throughout?
Sorry, I was on mute. We like the lasers.
Yeah, I think we want to leave the lasers on, gentlemen.
Jamie, I'm just doing some sort of back of the envelope calculations, and I wouldn't be surprised if this operation, the fill operation, takes like 3 minutes.
Right. Yeah, we have a much higher volume escape than we did yesterday, and we were there an hour and 33 minutes. This could be 10 times the amount of gas we were looking at yesterday.
Yeah, that's right.
Gentlemen, be advised that once we get the bucket over this, we may be looking at a fill cycle of only 3 minutes. So we're going to be looking at it pretty closely, and then be ready almost as soon as we get over it to get off it. You've now gotten over 3 minutes of video at this position, Tom.
Yeah, I think that's great, Jamie. I think when you guys are ready, we can proceed with the fill operation.
Okay, gentlemen, when you're ready, we can turn the lasers off and get the bucket over the seep.
Jamie, we will want to have a look up at the top of the bucket to see what it looks like before this. I'm sure you're doing that.
We want to, as I've said, we want to do a good visual inspection of the bucket before we move it, just to see if what we've collected. Want to have a record of what we see. And that blue light is on now, huh? Yeah, you might want to check it with both blue light on and off. I don't have a sense of what that is or isn't doing for us. We'll want to have it on and off during the fill just to see. You know, Tom, I certainly don't see any hydrate formation, but, and remember, we no longer have the structure for the string at the base of the, at the top of the flange. We have an emptier cylinder than we had the other day, but I'm not seeing any substantive formation of hydrate visually.
Yeah, I agree. We don't see it either. And we also really like that side view. The new side view of the bucket is pretty nice.
Yeah, the pilot cam view, I agree. That's really nice. And during the fill, gentlemen, video, we're going to want to see the pilot cam view and the head-on view as part of our quad. Okay, great. Thanks. Well, when you're ready, gentlemen, we can. I'm going to put the stopwatch on this one, so when you get over it, let me. We'll monitor it, but Tom Weber at UNH thinks it may be as little as 3 minutes. We'll have to look. We'll have to look and see it start to accumulate and get a real-time look. But you want to be ready to get off. No, I don't think you want to. I think you want to stay hovering if you can. Make your call. That's your call. Yep. I think that's why we put pilot cam the way it was. I think it's a great idea.
You get your stopwatch ready, Jamie?
Yes, I do.
Super.
Seeing bubbles in the Sirius cam now. I got a good view of that stream now.
This is going to be quite a piloting job, Jamie.
Yeah.
No easy task.
Very nice, gentlemen. I'm about to start it. Okay, stopwatch is on. Bubbles going into the cylinder. Very nice. Very, very nice. Well,
That looks beautiful.
I want to come right a little bit more. Yep, there you go. Very nice. Little over 1 minute.
That looks like a bullseye to me.
Yep. It's as close as we're going to get. Yep. We're starting to get hydrate formation on the underside of the top of the cylinder now. See it on the pilot cam. Two minutes. Yeah, approximately. I'm going to let him make that call. Very, very nice.
I think we're looking sort of between 10 to 15% full, Jamie. That's what we're shooting for.
Yeah, Tom says 10 to 15%. Right. We're not there yet. I'm looking at pilot cam. We're not even at 10 yet. Coming up, 2 minutes, 45 seconds.
So there goes my 3-minute estimate. See where
I think that view is fine. I don't think we have to move it. I think it's good. 3 minutes, 10 seconds. That's fine. If you want to switch that on to get a little bit of it, that's fine with me. It certainly shows up the ice a bit better. You can see the ice building below 10% now. Yeah, yeah.
From here, Jamie, the total volume still looks a little shy at 10%.
Yep, yeah, I agree with you because I think we're filling to the right a little bit more than to the left.
Yep, but we're certainly getting some stuff in there. That's
4 minutes.
going a lot faster.
Yeah, you can really see the uneven way that ice grows in the pilot cam. It's a really nice dual view. It shows you how asymmetric the accretion is of this ice inside the cylinder. It's fascinating. Some of the you can see some of the bubbles literally accreting against the ice as they come out, as they come in. It's fascinating. They're sticky bubbles.
It's more of Bob Carney's hydrate souffle, I think.
Right, there you go. 5 minutes.
Jamie, I'm guessing this is at roughly the 10% mark, maybe a touch more.
I think it's probably at 10% or a touch more. That would be my guess. 5 minutes, 53 seconds. Six minutes. You make the call, Tom.
Stand by.
Six minutes, 30 seconds. You're getting down near the 20% mark on the right side of the cylinder now. Seven minutes.
I'd say, Jamie, that we're pretty close here. It's making me nervous. So the next 10 or 20 or 30 seconds you can pull off probably, and I'd be fine.
Gentlemen, at 7 minutes, 30 seconds, start to leave. That's 8, 7, 6, 5, 4, 3, 2, 1. You can start to get out now.
Still has it. Still on it a little bit.
All right.
Very good.
7 minutes, 52 seconds.
Okay, I think next step is the same as last time. We start going up to 300 meters
Yep.
at your leisure.
General ascent, gentlemen, 10 meters a minute or approximately that, up to at least 400 meters, and we're going to start seeing things start to decay slowly as we did yesterday, I think.
That was a very impressive piloting job.
Okay.
Jamie, I know you guys are all working late tonight, so I don't know what your time constraints are, but my recommendation for this right now would be to come up to 400 meters and to hold steady at 400 meters, which will give us a little bit bigger margin of error as that dissociates and comes back to gas.
Hi, Tom. This is Erin. Jamie had gone to dinner, but I can relay that message to the pilot. You want to come up to 400 meters and hover at 400 meters?
Roger that.
Yeah, I think holding at 400 meters would make sense. That should be high enough where it turns back into gas and gives us a little extra room in case we overfilled a bit, which I don't think we did. Let's just be safe rather than sorry.
Sure. Yeah. They are set up to do just that.
Great. Thank you, Aaron.
You're welcome.
On the right side. Oh, actually, there you are. Okay, you see yourself? Looks clear. Yep, see the full tether? Okay. Cover up. So we're doing 10 meters a minute? 10 meters a minute. Okay. Push that up just slightly, just a little bit more. And Rockefeller up. 400, 400. Up at 2230. Pretty good view of you. It is far below me. Okay. Delta depth 20 meters.
So guys, get stretched out to see each other together, okay? Just make sure it's
Okay. What did survey want, sir? Oh, I'm pushing out a little bit. We're pushing out to get us some tether cams. Alright. Yep. Yep. That damn tether, so a bunch of stuff shake loose. Not millimeters. I think you're a little far below for tether cam right now. Yep. So, pushing up.
ROV passing 1100 meters. Temperature at the ROV 4.76 degrees centigrade.
Steady at 10. Separation is 29. Can you actually hold on yours for a second? Oh my goodness, slow down. Go slow down or just gonna do a stop? So, come to stop pretty quickly from 10. Yeah. Okay, delta's 19, 18, 17. Everything are heading a bit to port. Yep, just did that. Okay. Pushing out. Here's the slightly. 18.
RV passing 1,050 meters. Temperature 4.9 degrees centigrade. RV passing 1,000 meters. Temperature at Little Hercules 5.19 degrees centigrade. Vehicle passing 950 meters. Water temperature 5.37 degrees centigrade. Yeah, pilots, just so you know, we actually do log the tension coming out of the traction winch. So if you guys want to take a look at that post-process, we can to see what the max pull was today. Oh. That's funny. Vehicle passing 900 meters. Temperature at Little Hercules at 5.5 degrees centigrade. Okay, everybody watching from the beach, we're switching transmit 2 from the Sirius HD camera to the pilot cam on Little Hercules. This will give you another perspective of the cylinder and as the gas and the hydrates change. Little Hercules passing 850 meters. Water temperature 5.73 degrees centigrade.
Please pardon the interruption. Your conference contains less than 3 participants at this time. If you would like to continue, press star 1 now, or the conference will be terminated.
Hey, Aaron, this is Tom at UNH.
Yeah, Tom?
You made a comment about melting, and what I was wondering is, I see the area that you're referring to. What
Yeah.
I'm wondering is if you can tell whether or not there's hydrate formed on the bottom, because it seems like it would be melting a bit too early. And I'm wondering if those bubbles, the thought here from Kevin was that the bubbles were joining together as they expanded and combined to produce that smooth surface. And if
I
you
see.
can see if the hydrate skin on the bottom of that gas layer, that might be telling.
Right. Yeah, so I don't know if were you able to hear that? I can't hear.
Nothing I think that we could do to be able to determine that if we zoom, we're going to be zooming into here.
Right, so we can't really tell by zooming in on the bottom of it. I thought earlier that I could see it kind of moving, like as a fluid, but perhaps it would do that even if there was a thin skin there.
Yeah, once it's all joined, it has to be in contact with water for it to form hydrate, I think. So it could be, gas but if it's below the hydrate stability zone, we'd expect a thin layer of hydrate on the bottom, I think.
And even, it looks like the empty looking gaps, if you will, at the top, they look different. You know, how, but above that layer, it's kind of lighter white, and the gaps on either side look empty, whereas, you know, the bottom is full of water, right? So maybe that layer is keeping water from getting up there. I don't really know. What is here? Yeah. Yeah. Right. True. Would be that way anyway. I guess you're right. It would be that way whether there is a skin, if you will, of hydrate at the edge of that interface or not. No.
We've also, that the sort of part, the bubbly souffle part that's sticking down has grown actually since we started our ascent. Maybe it, anyway, even if it was melting, maybe those pieces just haven't melted yet, but if it was returning to gas and water, I would have expected that to get a bit smaller. But
you're saying that the temperature is still too low for you to expect it to exsolve?
I think it's a little deep and a little cold, but I could be wrong. We're probably getting pretty close. Maybe we've already passed the layer at which it changes. But we started observing that gas pretty early on.
Yeah.
Started as just a couple of light bubbles and has grown to be that sort of pool shape, and I think that's been for some time now. So my feeling was that it was a bit too early for it to be melting, but I could be wrong, Aaron. I'm only guessing from here.
Mm-hmm.
You'll have to give that to me on one of the DVIs that's not being used.
As Bob Kearney has pointed out, if nothing else, we've got a nice experiment with boil oil going on here.
I think that the only it's a non-ideal Boyle's law test though, because I think these bubbles are coated with other hydrocarbons. I don't think it's pure methane.
Hey, hi. Chilling with Dylan. Got a partial zoom going.
Tom, do you expect this cylinder to be 80% full, 90% full, 100% full? My recollection is that you thought this was going to be a ratio of about 1 to 5.7. Is that right?
Hang on a second. I'm going to just do the quick calculation. I think that if we stop at 400 meters, then we should expect it to be somewhere between 40 and 45% full.
So do I understand correctly that you do want to stop at 400 meters?
Yeah, I'd asked Aaron earlier if we could stop at 400 meters rather than 300 meters just to play it safe.
Roger that.
Anything, gentlemen? Hey, Brian, the goal with the quad was to replace the sonar.
Can I steal this for a while?
Oh, yeah.
GUI is now DVI3. That should do it.
Mm-hmm. So yeah, just a heads up to you out there on land. They changed the bottom right panel of the quad display to be the, I don't know what you, yeah, the ROV GUI, so you can watch the depth.
Do you know what GUI means there, Aaron?
Hey, I know that. Graphical user interface.
There we go. And now everyone out there knows it.
How about ROV?
Yeah.
Remotely operated vehicle.
She knows that one too.
Just checking.
What about EK60? I don't know that one.
Oh, that's a good question.
That's a brand name.
Yeah.
What about HMI? What does that mean?
Hydrojaride, what is it? Mercuric iodide or mercury iodide? Is that right? Hydrojaric mercury iodide or something like that.
Yeah.
Lights. They're lights.
I know
They're mercury vapor
I
lights.
know the lights.
I used to know that acronym. I looked it up once, and then I had trouble remembering it. I had to look it up several more times, and I'm still having trouble remembering. They're expensive lights. Yeah, our survey lead tells us that one HMI and one ballast for it, which equalizes the power output, is $40,000 US. It's amazing. But for those of you watching us, it just underscores what a valuable resource the Okeanos Explorer is. And believe me, the equipment is not as expensive as the people.
Hydrogyrum medium arc iodide.
Medium arc. Well, see, not too bad. What was it? What?
Medium arc iodide.
Hydrogyrum. That was the hydrogyrum. I was pretty good.
Yeah, very good.
Hydrogyrum. Medium arc iodide. That's it. Day simulating. Sunlight simulating.
Right. The gas pocket that's trapped at the top seems to be at the 20% mark now. And I can see it moving now and then.
Vehicles are passing 700 meters. The temperature is 6.59 degrees centigrade.
There you go.
We will pause the vehicles at 400 meters and watch for a while and see what the effect of staying at that depth, which is approximately the depth at which we lose the acoustic plume signatures from these seeps. We'll see what happens to our watery methane ice inside the cylinder. Have some confidence now that we have effectively sealed the top of the cylinder so that we will not be seeing gas escape through the top. We're hoping we see the gas begin to expand from the ice into the cylinder, and at the end will give us a relatively accurate assessment of the volume of gas we actually trapped in 7 minutes 52 seconds at the seep down below us. This is the Okeanos Explorer. That is expanding a bit now, that ice plug. It was not touching the 0.3 line before on our center view, and now it is. So it is beginning, that lattice is beginning to expand. It's probably because the gas inside the water ice cages, which are hydrate, beginning to expand a bit as the temperature rises and the pressure goes down. In fact, you can see changes now around the edges of that ice block. You can see the entire bottom of that ice block beginning to equalize and flatten out. I think that's probably gas now beginning to come out of solution, come out of ice formation with water. Very interesting. Happens pretty quickly.
So Bob observes that the meniscus at the gas-water interface does seem to have a hydrate skin from this camera angle. That's what we were trying to figure out earlier, is whether that gas part that we see at the top is just other bubbles kind of meshing together and forming basically one big bubble, and that there's still this skin at that interface.
You know, it's micro topography of temperature, and you know the pressure's the same, but there's probably a complicated temperature structure within that ice plug.
Yeah, I would think so.
And it looks to me like there's the ice is turning to gas both at the bottom and along the sides. Whether it's happening at the top, I don't know, but you can see the white part of the ice is shrinking a bit from the outside in. My recollection from yesterday is that it was happening very, very rapidly above 500 meters. We're now at a depth of about 660, 670 meters.
Yeah.
Talking about the white area there and up at the 100%, just from the perspective here, that might just be a reflection of the lights off the back of the silver. It might actually all be clear and only gas above 20%, now closer to 30%.
Wouldn't it be black behind it?
Now, in fact, you see the meniscus rotating a little bit there.
Yeah.
As the vehicle pitches occasionally.
Yep.
You can actually see that move, and it doesn't look like there's a solid above it from my point of view here. So it might not be black behind it just because of reflections of the lights off of the acrylic.
Perhaps. What do you think, video?
Maybe you guys should consider mounting that black plate, the backing plate, higher, so that it's blacking out, you know, that backing behind the whole part of the tube that we're mostly looking at.
I suspect more likely than not it's probably an oily residue from the methane, whatever came up with the methane bubbles.
Yeah, so what we're discussing is whether the white part that we're seeing above the meniscus is in fact still frozen methane hydrate, or whether it is just light reflection. And
I think it's frozen hydrate.
I think it is too.
If you go out and look closely, if you look very closely at the video, if you get very close, you can see the structure of the ice. This kind of worm-like structure of the ice in the central part of the plug. I think it's seeing a warmer environment and feeling less pressure, but it's probably feeling a warmer environment from the outside in.
Yeah.
Little Hercules passing 650 meters, temperature 7 degrees centigrade.
I mean, any kind of ice melting is going to melt from the outside in. You know, you have an ice cream cone on a summer afternoon. Center of that ice cream cone is the last part to go. Outer
Right.
part of it, you're licking like crazy to keep it from going because it's melting on the outside first. I think this ice is the same.
Yeah, and as Bob
The
observed,
center's the last part to go. You can't even see it.
Yeah, but I think you can see through the part. We're looking right at it, and I think we're looking through gas at the central plug. I don't think that's a problem. I think
About the ice cream cone, Jamie. I was talking about the ice cream cone.
Oh, the ice cream cone.
I'll be
Yeah,
quiet.
that's right. Webb never lets his ice cream cones melt.
yeah, and as Bob pointed out, most of the hydrate is now surrounded by gas, which is probably insulating it from the colder walls on the outside of the cylinder, or the actually, you mean the warmer walls of the cylinder?
Yeah, it's warmer. It's in contact now with water that's at 7 degrees centigrade.
Right. Because it's now not conductively heating that ice in the center.
I think time lapse will be very informative. Oh, I did. Yeah, I did. Yeah, 4 minutes. Yeah, it was good. I think this will be even more interesting, though, because you'll see the gas plug get larger as the... All we saw last night was the ice decaying and going away. That's right. And I think you're seeing the gas now begin to overtake the lower end of the ice. It's beginning to push down, and the transparent sides of the ice are gas, and it's pushing down below the edge of the ice and it's almost at the 0.3 mark now in the cylinder.
Seeing a couple bubbles come up from the funnel area.
Yeah, and that's right. You're getting a little hydrate down there as well. That's dissociating now. Yep. You just got less structure down there now, less to adhere to. Little Herc is now passing 600 meters, and the temperature is 7.47 degrees centigrade. Yeah, seeing a little of the effect of the gas. Yeah. Yep. Yeah, I think so.
It looks like for the boundary layer between the gas and the water in the column, there's less ice present now.
Right, it does.
15.2
Yeah, the meniscus does look
centimeters.
more liquidy now. You can see when it tilts up towards us, it actually wobbles and moves a little bit. From like you can see the reflections of that blue light on it.
Yeah, the ice is almost completely isolated within a gas pocket now. It's driving the water down in the cylinder. Look at that. That's wonderful. What a wonderful effect with the blue light. You can really see it.
I think the quality of it's a bit different. You can almost even see it clinging to the sides of the cylinder a bit more, because before it really seemed to move as a solid mass.
It's 10% of the volume of the cylinder. So it's 8333.771 cubic centimeters. It's 10% of that, and I don't know what the linear distance is between them. It's more than an inch, though. Right, it's more, maybe an inch and a half to inch 0.8, something like that. Yep. Yeah, that pilot cam idea was great, guys. That was a wonderful placement of that camera. Really nice. Genius at work. Looks like Rube Goldberg is working this time around. Proof that if you give engineers enough time, they do know how to plug a hole. That's good. That's really good. All right, here's a question. When will the ice leave the lid of the cylinder and float on the water? When will that happen?
8 minutes from now.
8 minutes from now? This is the hydrate lottery. At some point, I would expect it to break apart, but maybe not. It depends on what piece of it is still tied to the cylinder. Whether surface friction with the cylinder is more important than some kind of dissociation. Is the upper lid a very different environment because it's a different material than the what is it, plastic along the sides.
Well, right, and I mean, most of it is surrounded by air except for the lid, which is metal.
Is the lid metal? Plastic.
Oh,
It's
the top is
It's all,
plastic
it's
too.
all plastic, yeah, but it's different plastic.
Okay. I was trying to decide whether the top would conduct heat through and it would just detach from up there.
Well, I don't think that's it, but
But now it's plastic, so.
part of me is wondering when that will happen. The plug will get smaller and smaller, and at some point, will it fall and begin to float on the water plug underneath it as the water plug is pushed down the cylinder by the expanding gas? Kind of experiment you just tell 20 students and they run away for the night and come back with 20 different answers and a lot of Google research. You can see that left side really eroding now. Look at that left side begin to erode. You can almost see it.
Yeah, you can.
You can see it. You can see it start to go away. We're now at a depth of Little Herc's at a depth of 530 meters.
And temperature 8.2 degrees.
Question for you, Jeff. Would you mind if I put pilot cam on the big monitor for a minute? Take a look at it? Go for it.
Square meters times each of those tick marks is 4.5 centimeters.
Yeah, so a little less than 2 inches.
Get more detail.
1.7, 1.8.
It's a little bit overlap. Camera's not up to that much light. Yeah, Bobby and I were discussing if there would be anything falling between the two, but I can't see it if there is. Okay. 500 meters, wire out. Okay, thank you. 500 meters, 10 minutes.
Roger that. Just to reiterate, gentlemen, we want to pause Little Herc at 400 meters.
So what depth is that to go? I was going to ask if you wanted me to be about 10 or 15 meters. Do you have a preference? 10 or 15? Sounds good.
I've been holding the delta right at 10, so
We'll shoot for that.
it's 2.54 square, 2.54 centimeters per inch, so square that.
See the gas-water interface now just below the 0.3 line. It's kind of shimmering there. So the gas has now completely isolated the hydrate plug. It's now completely surrounded by gas. But of course, the hydrate itself is mostly water ice. So
It's funny, you could really see that left side melting away quickly before, and now it's not really.
well, I think there's some instantaneous change in the environment, in the temperature or pressure environment, and you'll get an erosion.
Yeah.
It's not a uniform ice. It's a pockety kind of ice, like a comet, and you'll just get a change. And then when we had pieces of it on deck, parts of it would pop and break away. Then other parts would be quite stable for a while.
When you had a piece of it on deck, was it that more solid kind, or
We
this
had both
kind
kinds.
of
We had both.
bubbly
We
kind?
had bubbly kinds, and
Okay.
but it was very uneven. Parts of it would bubble and hiss, and parts of it would sit there and were relatively stable, just looked like water ice.
I think once in a while I'm seeing, drops coming off of there and hitting that interface too.
Yeah, I think you're right. I'm not seeing much in the way of bubbles coming up from the lower flange, though. I think there wasn't much form down there.
Right, because it seemed like this time most of the bubbles were coming up, maybe not in the very center, but they weren't really hitting the flange and then crawling up the side like they maybe were yesterday or 2 days ago.
Look at this now, guys.
Oh,
look at
nice.
this.
There
See,
it goes.
Well, a piece of it broke away. See, a piece of it broke. A piece of it broke and is now floating on the water interface.
And now it's bubbling. I was thinking it would melt way faster after it gets in the water, kind of like water ice would anyway.
Right. And it's just forming bubbles like crazy now. Well, it's ice. Remember, it's going to float on the water. It's in the atmosphere. It's in a methane atmosphere, and it's floating on the water.
But you mean it's not like half of it is underneath and half of it is on top? It's just kind of melting right there at the surface.
Well, it's an ice that's mostly composed of gas, so you can't think of the iceberg analogy. It's not the same.
No, yeah.
It's the other way around. In fact, there. Look at it now. Look at it. It's great, wonderful.
It's really cool.
America's most memorable home videos. Here we are. Everything you wanted to know about water ice with methane attached. That's just great. I love that. Who says that Dave Lavalvo and his team cannot design a closed cylinder? Look at that. What are the speckles along the sides, though? Are those little residuals of ice?
I think so.
Is it still pieces of ice?
I think it is.
Yeah.
I think that piece kind of slid down the side a bit.
And there are little fragments of ice left?
Yeah.
Interesting. Okay, so you're down to the 0.4 division now of ice.
That'd be kind of like oily pieces of ice, perhaps, too, right?
Yeah. Oh, there's definitely some oil in this. No question about it.
Yeah, the interface does look kind of like a slushy now. Well,
I was curious, are you feeling that the vehicle's coming up any faster now that you have that much more buoyancy?
Not detectably, but in a moment here I'll go back against the Z-bias and we'll see what the effect is.
Yeah, I'd be curious to know. I'd be curious what it's going to take to control the rate of descent, given that we are adding a little bit of extra buoyancy.
Right. It's kind of hard to tell because it did seem like something had changed a few times, but of course the reach isn't 100% stable either.
Right.
No, Z-bias is going to be the better indicator. Tether drag is still the dominant factor, I think.
I haven't changed the Z-bias, so
I was just curious. Thanks.
we're just about at 400 meters now. Temperature is 10.3 degrees. Or that's serious, yeah. Yeah, I was thinking that we would see those little white specks on the sides disappearing here, but maybe they are just water droplets
It
or
could be
something.
water drops coated with oil.
Sure.
Could be something, there's a little bit of non-methane in there,
Yep.
higher hydrocarbon chain organic material. And my guess is that's what that is. That's the residual. We still got a plug of hydrate in the top of the cylinder, though. We're holding at 400 meters.
Do we?
Little harder. I think we do, yeah.
do we want any partial zooms on this?
Huh.
The real question is, do we want a consistent record? We won't be able to zoom. If we keep this, we can always.
I think we can leave this. I think we'll leave it the
Right.
way it is.
We can always zoom in further.
Yeah, I think
Yeah.
that's right. Tom, we're stable at 400 meters. I think I see some more hydrate up near the lid of the cylinder, but
Where? Can you point to it here? Where do you think it is?
oh, I think it's right. I think we've still got some right. I think we've still got some right here. I think, and I think it's isolated by the gas, but I might be wrong.
Unless it's just the glare from the light, because there's two spots.
Shining up the lid up there.
I think
Can't
it's.
tell, but we've also managed to hit exactly 40%, which means we're behind a yellow line, I believe.
Right.
Is that right?
Yeah, that is true.
It's
So
about-
you can't see the edges of that.
About
meniscus, huh?
40%, I think. Yeah.
We might want to come up to 350 meters so we can actually see the interface.
Good idea.
Yeah. Okay. Let's
We
not.
were too
I
accurate.
think.
Why don't we come up to 350 at 10 meters a minute, guys? Is that blue light is still on, isn't it?
Yeah.
I'm not sure that's helping us now. I think it was helping us when we had ice, but I'm not sure it's helping us now.
Blue light is something that can be quickly turned on and turned off because it is LED. But again, for consistent record.
No, I know. But visibility is. I mean, what we're debating is whether or not we see ice at the top of the cylinder.
The only observation I make with the blue light is that plastic at the top that forms the cylinder lid is white, and it appears pretty uniformly blue
Right.
in color, which indicates I think we're seeing most of the plastic.
Okay. Well, fair enough.
I don't know. It's hard to.
I don't remember looking well enough at it in the blue light before we had ice up there, so.
You know, if they look at earlier in the footage, they'll be able to make a really good comparative.
Yeah,
of an empty cylinder compared to.
Yeah, we may have lost all the ice. We may be done.
And I would agree with Brian. If we didn't have that blue light on, the bubbles or whatever it is that's sticking to the acrylic, you wouldn't be able to discern that from the background.
Right. So what Brian, our video person, was saying is that the top is uniformly blue because it's white, and the blue light is making it that way. So that helps us to see the contrast between the stuff that's stuck on the side of the acrylic and the top of the cylinder.
We're still on. When I consider stretching out a little bit more, especially as we're have a lot less cable. We're still zoomed in quite a bit. You want to come full wider picture?
So I'm starting to see that meniscus creep down underneath that line.
It's 20 meters slot range. Well, we could push out, but we're not in imminent danger here.
Why don't we just push out just a little, just recently? Okay.
Yeah, you're starting to see that gas water interface now push down below the 0.40 line, which you would expect as we rise.
Dropping at 350. 250 or 350? I thought it was 350. I said 2. Scared me. I'm coming up on 350. I'll go ahead and go to B40. Sounds good.
Hard to say, Tom, but it looks like your gas water interface now is somewhere in the 43 to 45% range.
Yeah, it looks that way to me, Jamie.
And-
I was thinking maybe we could hold for a minute at 350 meters.
Roger
and
that.
Make sure our vehicle is level and maybe try to get a zoom on that interface.
Right.
Should be right in the middle.
Gentlemen, let's hold at 350. And then video, let's get a zoom on that gas water interface if we can once we're stable and horizontal.
And holding at 340 right now.
And Little Herc is at 350.
Did you want to say that?
It would be good to push out.
Yeah, Little Herc is at 350 now. We're watching our meniscus move down a little bit. I mean, our gas water interface looks like it's at about, you can see it shimmering there. It looks like it's at about 45%. And maybe we can get a zoom on that when you get a chance.
Yeah, copy that, Dave.
Video, can we get a zoom on the,
Pilot, let me know when you're
oh, or,
ready.
fair enough.
Video, go ahead and zoom.
Very nice.
So Tom mentioned making sure the vehicle's level, but isn't there a slight pitch to the vehicle because of the...
Well,
I don't exactly know how to read that.
well, it's
Yeah,
it's an airplane
or-
level. It's
Oh, that's pitch and roll. Yeah, you're right.
Pilot indicated 3 to 5 degree pitch.
You let us know what you want to do, Tom.
What I couldn't tell is if this is like, this is the front and this is the back, or if this is you're looking straight out. So this is the left side, this is the right side.
Jamie, I think that's good. We can, I mean, we'll, from a frame grab here, we'll be able to trace out the front edge of that meniscus and get an estimate of what it is we have.
Do you want to come up and stop again, or are you good now to go to the surface?
I think we can just ride in the same way we were. I will enjoy watching that expand, and we'll continue to get good data on what's going on.
Okay, gentlemen, let's zoom back out and continue to rise at 10 meters a minute. We'll let you know if we want to stop again. Yep. What's the shallowest depth? I will let you know before that. Well, you got the info.
If we see you continue to drift south, that's forward underneath the ship, I'm going to ask you to drive north while coming up. Just to get into a steering position. Yeah, if you wanted to make that move now, I don't think there's any reason not to. It's up to you.
Hey, Jamie.
Yes, sir.
You just had a really, I think, smart idea, and that was to every time the gas or interface gets midway between yellow lines, maybe we should stop for a minute, zoom in, and get a good reading.
Right.
And that way, maybe we'll have a better idea about exactly what our volume is.
I think we'll be able to do that 2 or 3 more times. Once they get above 200 meters, I think we're going to want to come up.
Okay, 2 or 3 more times would be great then, if you can do it.
All right.
Pilot video, can you check that the tilt is at full up? You might have got a little creep compared to the other one.
Gentlemen, I'm going to want you to stop again at 300 and 250. Did you copy that? I'm going to want you guys to stop again at 300 and at 250.
Copy 300 and 250, Wesley.
Yeah, those depths probably won't exactly be, we should just gauge it based on what we're seeing, Jamie, because that'll start to happen sooner and sooner as it expands at a fast rate.
Yeah, we'll just keep watching it.
problem. I'll be good.
Video will want to take a look, get a zoom again at 300 meters.
Copy that. That's a good thing. Only at 290 wire out.
We are holding Little Herc at 300 meters, and when you're stable and horizontal, video, if you would give me a zoom, please.
Dave, Tom wants to know if the 50% mark is at the top or the bottom of the yellow tee.
50% is the top of the yellow tee.
Okay.
Yep, that's great. Now, gentlemen, what we want to do next is actually get that gas-water interface down below the next yellow line. So I'm not sure that's going to be at 250 meters. So I suggest we rise 10 meters a minute, and when we see it about at midway between those next two divisions, we stop.
You're back full white power. Coming up. Let's go. You guys are in a pretty good stream configuration here. I'm just going to make the ship started at point 3 and get set up for recovery. Sound good? Yeah. Real jar over there. You made it. You start coming ahead at point 3 now. Thank you.
That's the idea. Just trying to get enough punctuated stops so that we can they can determine some rates, and we've got the temperature record, we've got the depth record, so.
You guys have added a new depth gauge. That's true. You could calibrate this as a very accurate depth gauge. The depth thermometer.
Something real for a managing the surface.
Yeah. Or you could make it smaller. 100%, which would be the same.
Well, look at that interface. When the vehicle moves, you can watch that interface just move back and forth. It's great.
You guys are streaming nicely there. No, you probably don't.
It's on the third a little bit more. Thanks.
Looks to me like 240 would be good, so we'll stop at 240.
Okay,
Dave, the next modification is you could put a little LED at the top of the image. Thanks. Welcome with us tomorrow. TC. Maybe it'll be Christmas snow tomorrow. Okay. Maybe from the inside. It's a little inflated there. Pick one, Sean. That surface that just tipped towards us was very reflective.
Well, that's the gas water interface. It's quite reflective.
240 wire out. I'll go ahead and get a 230. I'll cross the 250.
And you look down from the atmosphere into seawater if you've got light, it's quite reflective. It's a free surface. Yeah, 240 is going to be good, gentlemen.
You've probably seen this, Jamie, right at hydrothermal vents where if you have water sometimes pooling under flanges, it looks like a mirror.
Completely reflective.
Pretty cool.
Yeah, it's completely reflective.
And that's just different water of different temperatures.
Exactly.
Rather than a gas and a water.
Great. And then when you're stable, video, if we could get another zoom when you're stable. See the top of the interface there, that's great.
Yeah, you can see that pretty clearly now.
You could probably take auto head off if you want to. Should be screaming at the box.
What do you think, Tom? Have you got enough?
Yeah, I think this looks great, guys. This is really wonderful. Thank you. I think you're good to recover on deck and don't smoke while you do it.
Roger that. Nice job, gentlemen. I think we're good. We're good for the surface. I think that's your discretion. I think we're done.
Ready to come up, please? Alright, Kevin. Let's go home.
Fantastic dive today, guys. Thank you very much.
I think they did good. And we will start to see that gas come out the bottom of the cylinder here relatively quickly. But that's a controlled experiment. That's not what happened yesterday.
Great job, you know. Hey, could you make a 15-minute announcement?
The vehicles will be at 50 meters in 15 minutes. The vehicles will be at 50 meters in 15 minutes.
Yeah, Tom, what's your feeling now? Do you want to go back to the same vent and use the grid tomorrow?
Well, if that's a possibility, I know you guys are having a late night and there's some equipment change.
I don't think that's I think the grid, depending on how long you want to look at bubbles in front of it, that's not going to be a huge long time. I think our view is we want to get you at least one shot with the grid, and if this is the spot, we'll do it, and then save the 18th, the day after tomorrow, for another shot at a bucket experiment at Biloxi B.
Yep, I agree. I was just wondering. I know there's Dave and team. It takes some time to change out the methane bucket to the grid. I didn't know what personnel constraints.
These guys live to serve. They live to serve. So Dave he's rabid to use that grid. He made it and he wants to use it. So.
Well, I'd like to see it used too, and I'd like to go back to I've got a draft dive plan. I'll send this out to you guys right away, but I'd like to go back to the same site where we did this. That'll be an intercomparison between the two methods, and then that we saw first on this dive, which is also the more dispersed one,
right?
Which is also, I believe, we saw on Lake 2. I'd like to use the calibrated grid there as well.
Yeah, that's not a problem. They're very close together, and I don't think that's going to be an issue. I think we can once we're down there with the grid. There's not a lot of complexity about sitting and seeing bubbles come up in front of the grid. That's just a case of positioning ourselves and shooting video. So there's none of the complexity related to capturing bubbles. I don't think that's a problem.
Yeah, okay, great. The advantage of going back to the site we just visited where we did this experiment is we'll have the intercomparison. But at that dispersed site, I don't think we could get a good measurement with the bucket, but hopefully we'll be able to get it with a grid. So we might be establishing a nice complementary method for doing this. You know, sometimes the grid's good, sometimes the bucket is good.
Yep.
So I'm looking forward to seeing it.
Well, just make sure, as I understand, you'll be in Washington a lot of the day tomorrow. Make sure that Kevin's got a sense of how long you would want us to shoot video in front of these streams.
Yep. Yeah, we had talked previously about 5 minutes. I think that's still a good estimate. Kevin's standing here, so he's listening to this conversation.
Gas is about to come out to the base of the cylinder and go out the flange. You can see the gas-water interface at the base of the cylinder now.
Now, that's not sealed there, right? That's bolted on?
Yep. Well, that's great. So shoot us a dive plan, and if you can also give us, before you head out, a half a page to a page of summary of this, that would be great.
Okay, will do.
Yeah, you might also help us understand what you would like to do tonight. We're here at Pascagoula. We're not going to be able to go back to Biloxi tonight. It's too far. So let us know what you would like to do, what you would like the ship to do tonight.
Well, I think a pass or two over this area where we've just been mapping is good. We'll want that right after this, as soon as reasonable after this dive, and then prior to the dive tomorrow morning.
Okay.
We'll want it again.
Okay.
After that, if you're, we'll take those passes as long as you can give us, but there might be some unmapped area to the north of here. I'm not sure the fast you're mapping.
Okay. We'll do that. We'll give you a pass or two tonight, as soon as possible after the end of the dive, and a pass or two in the morning before we start. And the rest of the time, we'll map where we need to map.
That sounds great, Jamie.
All right. Hey, pleasure working with you. Wait for the gas bubbles to start coming out of the flange here pretty soon. Any second now, we're going to start seeing them.
Yeah, we're waiting for the finale, the grand finale here.
Yeah. Anybody got a torch? We can send Dave's bucket up like a Roman candle. That cylinder's completely full of gas now.
It's actually quite a seal at the interface between the cylinder and the funnel. I don't see much of.
There you go. Starting to.
Oh, there we go.
Just let yourself float up, breathe, and thrust down.
Hey, you can see bubbles starting to escape now. Yeah.
You're seeing something flogging on the glass.
Serious tilt to the vehicle.
Well, it's pretty cold gas, so and the temperature is, I think, could be temperatures up to 20 degrees centigrade in the water. So you get up above the thermocline here, it gets warm fast.
I just wondered how you'd like to set up for recovery. Copy that. Sounds good. Cheers. Coming up a little bit? Yeah. Looks like about 20%. That's good. That's a bit different.
What's the volume of the cylinder?
3,000 or 8,333.771 cubic centimeters.
Please pardon the interruption. Your conference contains less than 3 participants at this time. If you would like to continue, press star 1 now, or the conference will be terminated.